Today we're looking at lesson 5.2 for geometry on medians and altitudes of triangles. We'll also look at something called an orthocenter and find that as well. So the first part is when you're talking about medians, and a median, it explains, is a segment with endpoints being a vertex of one of the parts of the triangle and then the midpoint of the opposite side. So they've shown you this here. And then every triangle has three medians. Okay, so if I drew another one, I would have, let's say, one coming from A, and that would split BC into two equal parts, and then one coming from B, which would split AC into two equal parts. And it says the point of concurrency of the medians of a triangle, meaning the point in the middle, which is right here, would be called the centroid. And that's always inside the triangle. So it talks about the centroid theorem, which is the medians of a triangle intersect at a point called the centroid, which I said. So in this case, P is the centroid. And then P would split the lines coming from the vertices to the opposite sides into thirds. So you'd have one part of the line be 2/3 and one part of the line be 1/3 of the total. So with that information, we're going to find different parts of these lines here, these medians. So it says you have triangle ABC, which is the large triangle. It gives us FC, which is 15, so all the way down there. And notice that FQ is the smaller part of that line, so that's going to be the 1/3. And then 2/3 of the line is going to be QC, which is the larger part of that total FC. So FQ is going to be 1/3 of 15. So that means we're going to multiply 15 times 1/3, which gives us 5 to get our answer. And then QC is going to be 2/3 of 15. So we're going to multiply 15 times 2/3 and get 30/3, which simplifies to 10/1, or 10. And that would be how we would find different parts of the lengths of the medians. Now you have triangle JKL. This time it gives us RP is 3.5, and JP is going to be 9. So what that tells me is that RP is going to be 1/3 of RL, and JP is going to be 2/3 of JS. So if we're going to find the parts here, to find PL, which is the other part of RL right here, that's going to be 2/3 of the total, and if we have 1/3 is 3.5, we're just going to multiply 3.5 by 2 to get 2/3, which would give us 7. And then the total RL would be 7 plus 3.5, which would give us 10.5, but it's not asking for that. And then we have PS, which is 1/3. So if we're given 2/3 of that, we're going to take 9 and divide it by 2 instead of multiply, which gives us 4.5. And that is 1/3 of the line JS. The total JS then would be added together, 9 plus 4.5, which gives us 13.5. And that is more working with the centroid and the median lengths. Now the next part is thinking about a centroid in real life, and the centroid is actually the most center point of a triangle. And if you're trying to balance something that's a triangular shape, that would be the best place to balance it. So if we're trying to support here a triangle that it says, we're basically asked to find the centroid, so the middle point. And there's a step-by-step process in finding the centroid, and this might help to have graph paper. So if you have graph paper, graph this along with me. I cannot make my graph paper because if it's graph paper, I have to start in the very beginning with graph paper. So I'm just going to do this without graph paper, but I would graph it first. So the points here of the triangle are 0, 4, and 6, 11.5. Okay, sorry, I had to redo my scale here because I have larger points than I thought. So 0, 4 is what we're graphing here. 1, 2, 3, 4. And then we have 6, 11.5. And then we have 12, 1. And those are our 3 points. And to find our centroid, the first thing we're going to do is we're going to find the midpoint of one of the medians. So I would go from the top median here straight down. So here, this point, straight down in order to find my median. And if I'm trying to find the midpoint of this line, I have put a point here for A and C. I labeled them as letters so you can tell a little bit easier what I'm talking about. So if I'm trying to find the midpoint of AC, I need to get the 2 coordinates for A and C and use the midpoint formula to find the midpoint of this. Whenever you're trying to find the centroid, I would always either look for a way to draw a vertical line straight down to another part of the triangle, or I'd draw a horizontal line across, because once you start getting into diagonal lines, then you're going to need to use the distance formula, which gets a little bit complicated. So that's why I chose to go from B straight down vertically through AC and use the midpoint of AC as my starting point. So the midpoint of AC would be taking A, which is 0, 4, and C, which is 12, 1, and adding the x's. So 0 plus 12 over 2, and adding the y's, 4 plus 1 over 2. And that would give us our midpoint. So 12 over 2 is 6, and 4 plus 1, 5 over 2 is 2.5. So this point here, which we can call point D, is going to be 6, 2.5. And if you're using graph paper, this would make it would be very clear that it's at 6, 2.5. Mine looks a little bit off here on the y-axis because my graph is not completely straight. But if you're looking at a graph with graph paper, it's going to be straight, so it's going to be exactly at 6, 2.5. So that's your first step, is to find the midpoint of one of the sides of the triangle by drawing a median down from one of the vertices. The second thing you're going to do, and this is why you want either a horizontal or a vertical line for your median, is you're going to count the distance of the median. So from B, point B, to point D, vertically, the distance would be 11.5 minus 2.5, because those are our y coordinates. So if we do 11.5 minus 2.5, that gives us 9. So the whole distance of BD is 9. And if I'm trying to do the centroid, I would take 2/3 of that, or you could even do 1/3 of that, and you could find the centroid. So if you're going to do 2/3 of 9, you do 9 times 2/3. That's 18 over 3, or 6. So from B down, I would count 6. So 11.5 minus 6 is going to give me 5.5. So my centroid point is going to be over 6, but up 5.5. Right here. So this point is 6, 5.5. And that would be my centroid. Next, we're going to look at orthocenter. And orthocenter is a little bit different than a centroid. You have what's called the altitudes of a triangle, and the altitudes are going to be from a vertex, just like the median, but it's going to be perpendicular to the side. So no matter where the side is, it's going to have to be straight down from the vertex to the other side. Sometimes it might be outside of the triangle, sometimes it's inside, but it's always perpendicular to the opposite side. So it's a little bit different than median. Median doesn't have to be perpendicular, it's just splitting the other side into two parts, equal parts. Orthocenter doesn't have to split the side into two equal parts, but it has to be perpendicular to the opposite side. So we're going to find the orthocenter for our last example, and this is pretty lengthy in terms of the steps, so we're going to take it step by step here to find the coordinates of the orthocenter of this triangle. Again, I would use graph paper. Makes it easier, it's straighter, but again, I don't have access to graph paper on here, so I'm going to do the best I can to show you without graph paper what the steps are. So let's start. We have triangle ABC, and we would graph that first. So triangle ABC has 0, 6, 4, 0, and negative 2, 4. So a point here. Point here. And a point here. So this would be our triangle. And this is labeled as A, B, C. So that would be my first step, is to graph the triangle. To find the orthocenter, we're going to find the point where 2 of the 3 altitudes are intersecting. So to do that, we need to find an equation of one of these altitudes. Now, it doesn't matter which altitude you start with. Let's say I do C to AB. So that means it's going to be going from C down to AB. Okay, so I'm going to need to find the slope of AB because I know that my altitude has to be perpendicular to that slope. So that'll help me be able to find my equation. So first, my slope is going to be for AB. I need to find the slope. My points are 4, 0, and negative 2, 4. So my slope is going to be 0 minus 4 over 4 minus negative 2. That gives me negative 4 over 6, or negative 2/3. Now, the perpendicular slope to that, which is going to be my altitude coming from vertex C, is going to be flipped, and it's going to be opposite sign. So my perpendicular slope is going to be positive 3 over 2. So to find my equation from vertex C down to AB, that altitude, we're going to find the slope, which we just did, by making it perpendicular to the line we went to. And then since we have point C given to us, we're going to plug in point C for x and y to find our B value. And that'll give us the equation for that dashed line here. So point C was 0, 6, 6. So we're going to put in 6 for y, 0 for x, solve for b. So that gives us b is 6. So my equation for that dashed line is y equals 3 over 2x plus 6. So that's our first step, is to find the equation of one of the altitudes. Now our second step would be to find the equation of another one of our altitudes. So let's say I do the altitude b over to line CA. That means we're doing the same steps as we did before, so we need to find the slope of CA this time, which C is 0, 6, and A is 4, 0. So the slope of here is going to be 6 minus 0 over 0 minus 4, 6 over negative 4, which simplifies to negative 3 over 2. So that's the slope of CA. And then so the altitude coming from point B is going to use the opposite reciprocal slope, which is 2/3, positive 2/3. Set it up in slope-intercept form and use point B now to find the B, or the y-intercept. So point B is negative 2, 4. So 4 goes in for y, negative 2 goes in for x. We get negative 4/3. So 4 equals negative 4/3 plus b. Negative 4/3 is the same thing as negative 1 1/3. So if I'm adding it to the other side, that's going to give me 5 1/3 for b. So my equation would be y equals 2/3 x plus 5 1/3. And that is for the orange altitude. So now we have two equations of our altitude. And once we find two equations of the altitude, the point that they intersect at, that's going to be our orthocenter. So we need to solve the system of equations. So I'm going to write these two equations on the next slide. So y equals 3/2 x plus 6. And y equals 2/3 x plus 5 1/3. And to solve, I can put them equal to each other, since they're both equal to y, almost like using substitution. And solve for x first. So combine our x's. 3/2 minus 2/3. Need a common denominator, which would be 6. So 9, 6 minus 4, 6, which is 5, 6, x plus 6. And then we need to subtract our 6. So we have 5 1/3 minus 6, which gives us negative 2/3. So 5, 6x equals negative 2/3, and multiply by the reciprocal to get x. So I get 12 over 15, or negative 12 over 15, which simplifies to be negative 4/5. So that's our x value. And then we're going to plug in negative 4/5 into either equation. Let's just take the first one, y equals 3/2 x plus 6. And solve for y. So I get negative 12 over 10 plus 6. Get a common denominator. Negative 12 over 10 plus 60 over 10, which is 48 over 10, or 24 over 5. So y would be 24 over 5. And that would be our orthocenter. Excuse me. Need to go get some water. And that concludes lesson 5-2.